This lab observes a spice jar rolling in the positive x direction at a constant velocity, supporting Newton's second law and demonstrating that when net force is equal to zero, the velocity is constant. This system that we are looking at is the moving spice jar, and the surroundings are everything else. Newton's second law is that net force is equal to mass times a change in position over change in time. My goal for this lab was to show that when net force was equal to zero, there would be no acceleration, and the spice jar would move at a constant speed in the same direction. We were interested in this lab because it allows us to support a standardized rule for the movement of objects, especially when net force is equal to zero. On this screen, we have the four most important equations relevant to this lab. The position update formula allows us to solve for the velocity, given that we know the starting position and ending position, as well as time. The velocity update formula allows us to see whether there is a change in velocity from the beginning to end, and since Fnet in this case was equal to zero, the final velocity was equal to initial velocity. Finally, we have Newton's second law / the momentum principle. As mentioned earlier, these principles shows that net force changes the momentum of an object, and therefore, disregarding mass, the velocity as well. I chose to model the results for this lab in a position versus time graph. In this model, the blue line represents the observed values based on the video analyzed by tracker software, and the orange line represents the values based on the GlowScript data. It is clear that both the observed and predicted values have a constant slope, meaning that they both represent constant velocity. This is just a quick overview of how I collected data through Tracker. I traced the spice jar all the way through each frame and then exported the data from the bottom right to Excel to put into the position versus time graph. The reason that I chose to use a position versus time graph is that A, it was the two most easily observable data points from the lab, and B, the slope of the position versus time graph is equal to velocity, so it was easy to see that the slope was constant, therefore velocity was constant. Here, I've included the position versus time graph as well as the velocity versus time graph from the predicted values via GlowScript. As you can clearly see, when the correct values were entered into GlowScript, the program can precisely estimate where the object should be at every single moment. This can then be translated to the velocity versus time graph as a straight line with no slope, meaning zero acceleration. These differ from the observed value slightly since it can be completely controlled in code, but it's very similar to the observed value. In order to calculate the velocity value for this code, I took the initial position of 0 meters and subtracted it from the final position of 1.9395 meters and divided it by 1.701 seconds to get a velocity of 0.797 meters per second. So what if we flipped it so that the jar was rolling in the negative x position? If it was flipped this way, it would still have the same absolute value of the slope. The velocity would be negative 0.797 meters per second instead of positive, but the ratio of position to time would not change. So what does this mean exactly? Firstly, since Fnet is equal to zero, the observed values and the predicted values are very accurate to each other, showing that there is indeed a constant velocity with the spice jar rolling. It would be extremely difficult to say exactly how many forces are acting on the spice jar to get a net force of zero, but some examples include the force of gravity, the force of the floor on the spice jar, and the force of the push. But what we do know for this case is that it all equals out to zero. Looking forward, some of the potential errors that could be found in this lab included grainy flooring or the floor not being exactly level and the video not being shot in the best way. So moving forward, I would want to roll on a less friction surface, maybe it's like ice, and have a better video angle to make it a better lab. Just some quick conclusions. The lab once again supports Newton's second law, which says that Fnet is equal to zero as velocity stays constant, and there is no significant change in velocity. The rolling of the spice jar is just a minuscule lens into the power of Newton's second law and how it can continue to be supported on a larger scale.